Hello there, and welcome to the SleepScience channel. I'm so glad you found your way here. Tonight, we'll journey through 100 facts about the universe. Some you may have heard, but most will be new wonders to rest with. And in exploring these distant stars and quiet mysteries, you might just find that the line between you and the cosmos is softer than you think. Before we begin, take a slow breath. Let it settle wherever it wants to go. There's no rush. Each fact is a small piece of the vast, quiet dark that surrounds us. You don't need to follow every word, just let them carry you. Now, let's begin with the first of these 100 wonders. Universe may be older than 13.8 billion years. The universe may be older than we think. For decades, you've been told it's 13.8 billion years old. But recent observations suggest it might be closer to 26 billion years, nearly twice as ancient. Distant galaxies appear more mature than they should, as if they've had more time to grow and spiral into form. The numbers don't quite fit. And so the cosmos holds its age like a secret, older and quieter than our equations allow. Not all planets orbit stars. Out there in the dark, thousands of rogue planets drift alone, untethered from any sun. They were ejected from their solar systems long ago. Gravitational chaos flung them into the void. Now they wander through the space between stars, cold and silent, lit by nothing but the faint glow of distant galaxies. You might think a planet needs a star to exist, but these worlds prove otherwise. They move through darkness, carrying their own quiet stories, unseen and unanchored. Universe may recycle through infinite cycles. Some scientists believe the universe doesn't end, it resets. In this model, the cosmos expands and contracts in endless cycles. Each Big Bang is followed by a big crunch, which births another Big Bang, which births another universe. On, like breathing. If this is true, then everything you see, stars, galaxies, the atoms in your body, has been here before, in some other form, in some previous cycle. The universe might be far older than any single iteration. It might be eternal, endlessly renewing itself, like waves returning to shore. Oldest light comes from 380,000 years after Big Bang. The oldest light you can see is not from the beginning. For the first 380,000 years after the Big Bang, the universe was too hot and dense for light to travel freely. It was opaque, a glowing fog of plasma. Only when things cooled enough did light finally break free and begin its journey across space. That first light is still traveling. We call it the cosmic microwave background. It surrounds you even now, a faint whisper from the universe's infancy, stretched and cooled by time, but still here, still moving. A memory made of photons. Diamond planets exist around dead stars. Some planets are made of crystal. Around white dwarfs, the cooling cores of dead stars, astronomers have found planets made almost entirely of carbon. Under extreme pressure, that carbon has crystallized. These worlds are essentially giant diamonds, spinning silently in the dark, catching no light, shining for no one. They're remnants of something that once burned bright. Now they're cold, compressed, beautiful in a way no eye will ever see. A monument to what remains when the fire goes out. Universe may have no edge, just endless curvature. The universe might not have an edge. If space curves back on itself, like the surface of a sphere, then you could travel in one direction forever and eventually return to where you started. There would be no boundary, no wall marking the end, just continuous curvature wrapping back endlessly. It's hard to picture because you're used to edges. But the cosmos may simply fold into itself. Infinite in the sense that it has no border. Finite in the sense that it contains a specific amount of space. A paradox held together by geometry. Sun once had a twin star. Your sun may have once had a twin. Most stars are born in pairs, binary systems where two stars orbit each other. Our sun likely formed alongside a companion, another star that shared the same stellar nursery. But over time, gravitational interactions pulled them apart. That twin is still out there, somewhere in the Milky Way, moving through space on its own path. You'll never see it. It's too far now, lost among billions of other stars. But once, long before Earth existed, the Sun was not alone. Neutron star material has extreme density. A neutron star is dense enough that a teaspoon of it would weigh more than Mount Everest. When a massive star collapses, its core compresses to unimaginable density. Protons and electrons are crushed together into neutrons, packed so tightly that a sugar cube-sized piece would weigh about 1 billion tons on Earth. These are the densest objects in the universe, after black holes. They spin hundreds of times per second, silent and cooling, the compressed hearts of stars that once burned brighter than galaxies. Now they're just heavy. Impossibly, quietly heavy. Gravitational lensing creates multiple galaxy images. Sometimes you see the same galaxy more than once. Massive objects, galaxy clusters, black holes, bend space-time around them. When light from a distant galaxy passes through this curved space, it splits and bends, creating multiple images of the same object. You might see the same galaxy 3 times in one photograph, arranged in an arc or ring. It's not 3 galaxies, it's one, viewed through the warped fabric of space itself. Light finds multiple paths around the obstacle, and each path shows you a slightly different view of the same distant world. A cosmic mirror held up by gravity. First stars burned 1,000,000 times brighter than Sun. The first stars were giants, born from pure hydrogen and helium before any heavier elements existed. These ancient stars were hundreds of times more massive than our Sun. They burned with incredible intensity, flooding the early universe with light and heat. They didn't last long. Stars that bright burn out quickly, collapsing into black holes or exploding as supernovae within just a few million years. But in that brief time, they forged the first heavy elements: carbon, oxygen, iron, seeding the cosmos with the building blocks of everything that came after, including you. And nearby, in the same vast dark, other mysteries wait to be named. If your mind has already started to wander, that's exactly what should happen. There's no need to follow every word. Here's something else to rest with: dark matter and cosmic dance. Dark matter streams through you constantly. Right now, dark matter is passing through your body. You can't see it, can't feel it, can't measure it directly, but it's there. Invisible particles streaming through Earth, through walls, through you, as if you weren't solid at all. Dark matter doesn't interact with normal matter in any way we can detect, except through gravity. It makes up about 85% of all matter in the universe. The stars, planets, and everything you can see, just 15%. The rest is this silent, invisible presence, flowing through space like a current you'll never touch. Always there, always moving, always unseen. Some galaxies glow without stars. Not all galaxies shine with starlight. Astronomers have found galaxies that glow faintly, not from stars, but from diffuse gas clouds heated by cosmic radiation. These ghost galaxies contain almost no stars at all. just vast clouds of hydrogen drifting in the dark, glowing softly like embers without flame. They're hard to find. They don't announce themselves, but they're out there, scattered across the universe, quiet and dim. Places where matter gathered but never quite ignited into stars. Almost galaxies. Whispers of what could have been. Cosmic cold spot challenges physics. There's a place in the sky that's colder than it should be. In the cosmic microwave background, that ancient light from the universe's infancy, there's a region that's significantly colder than the surrounding space. It's called the cold spot, and no one knows why it's there. Some theories suggest it's a statistical fluke. Others propose it might be evidence of parallel universes pressing against our own, leaving a cold imprint where they touch. Most likely it's something simpler, but the universe holds its answer quietly, and the cold spot remains, a mystery written in ancient light. Moon slowly drifts away from Earth. Every year, the Moon moves a little farther from Earth, about 3.8 centimeters per year. It's tidal forces, the same forces that create ocean tides, that gradually push the Moon outward. Billions of years ago, the Moon was much closer. The days were shorter, the tides were higher, and the Moon loomed larger in the sky. In the far future, it will be so distant that total solar eclipses will no longer be possible. The Moon will appear too small to cover the Sun completely, but that's billions of years from now. For your lifetime and many lifetimes after, the Moon will still hang close enough to light the night. Binary stars exchange matter like dancers. In binary star systems, sometimes one star feeds on the other. When two stars orbit very close together, the more massive one can pull matter from its companion, long streams of gas flowing between them like ribbons. It's called mass transfer. The donor star slowly loses mass while its partner grows heavier. Over time, the balance shifts. What was once the larger star becomes the smaller one, and vice versa. They dance around each other, exchanging matter, locked in a gravitational embrace that can last for millions of years. Not destruction, just transformation. A slow exchange of self. Vacuum of space has quantum activity. The vacuum of space is not truly empty. At the quantum level, particle-antiparticle pairs constantly pop into existence and annihilate each other in fractions of a second. It happens everywhere, all the time, tiny bursts of energy flickering in and out of reality, too brief to measure directly. This quantum foam gives the vacuum a subtle energy. It's one of the strangest predictions of quantum mechanics, and it's been confirmed experimentally. Even nothing, it turns out, is something. The emptier space still hums with invisible activity, a field of potential that never fully rests. Time travels at different speeds in universe. Time doesn't flow at the same rate everywhere. Near massive objects, black holes, neutron stars, gravity warps space-time so severely that time slows down. If you could orbit close to a black hole and then return to Earth, centuries might have passed here, while only years passed for you. This is not science fiction, it's relativity. Time is flexible, shaped by gravity and motion. A clock on a satellite ticks faster than one on Earth's surface. By tiny amounts, yes, but measurably. Time is not universal, it's local. It bends. Some stars orbit galaxy backwards. Not all stars orbit the galaxy in the same direction. Most stars, including our Sun, orbit the Milky Way in the same direction, following the galaxy's rotation like cars on a highway. But some stars move in the opposite direction, retrograde orbits that cut against the flow. These are often old stars, captured from smaller galaxies that the Milky Way absorbed long ago. Or they were flung into unusual orbits by gravitational encounters. They're travelers moving against the current, following paths that don't match the rhythm of the galaxy. Outliers in the cosmic dance. There's something worth pausing to notice. Every fact we've touched carries a quiet truth. The atoms in your body were born in stars. You are not separate from these stories. You are made of them. And now, back to the cosmos. You're traveling through space at incredible speed. Right now, you're moving faster than you can imagine. Earth spins on its axis at about 1,600 kilometers per hour. At the same time, it orbits the Sun at 107,000 kilometers per hour. And the Sun itself orbits the center of the Milky Way at roughly 800,000 kilometers per hour. Add it all up, and you're traveling through space at speeds that would make any spacecraft seem slow. But you don't feel it. The motion is constant, smooth, carrying you along with everything else. The air, the ground, the oceans. You're moving, always moving, through the vast dark. There's something peaceful in that. You're not still. You never were. You're a traveler, even when you're resting. Even now. Space has no up or down. In space, there is no up or down. On Earth, gravity gives you a sense of direction. Down is where things fall, up is where they rise. But in the emptiness between stars, there's no absolute orientation. Every direction is equally valid. North, south, up, down. These are just words we use because we need them here. Astronauts in orbit often say it's disorienting at first, then freeing. Without an absolute frame of reference, you can reorient yourself however you like. What was the ceiling becomes the floor. What was forward becomes backward. The universe doesn't impose direction. It simply is, vast, open, holding you without telling you which way to face. And maybe that's another kind of permission. To exist without needing to know which way is up. There's no need to hold on to any of this. Just let it wash over you. If you've drifted off, that's perfect. Light takes 8 minutes to reach Earth from Sun. The sunlight touching your face right now is 8 minutes old. Light travels at 300,000 kilometers per second, but even at that speed, it takes 8 minutes and 20 seconds to cross the distance from the Sun to Earth. When you look at the Sun, through clouds, never directly, you're seeing it as it was 8 minutes ago, not as it is now. If the Sun suddenly disappeared, you wouldn't know for 8 minutes. The sky would stay bright, the warmth would linger, and then, all at once, darkness. But the Sun won't disappear. It will burn for billions more years, sending light across the void, always 8 minutes behind itself. Most stars are smaller and dimmer than Sun. Our Sun is brighter than most stars in the galaxy. About 75% of all stars are red dwarfs, small, cool stars that burn slowly and last for trillions of years. They're so dim that none are visible to your naked eye, even though they're the most common type of star in the universe. The Sun is relatively bright, relatively large, relatively hot, and because of that, it has a shorter lifespan, only about 10 billion years. Red dwarfs will outlive it by magnitudes. Slow, quiet, invisible. They'll be the last stars burning when everything else has gone dark. Jupiter protects Earth from asteroid impacts. Jupiter acts as Earth's shield. Its massive gravity pulls in asteroids and comets that might otherwise strike Earth. Over billions of years, Jupiter has absorbed countless impacts, protecting the inner planets, including ours. Without it, life on Earth might have faced far more extinction events. You owe something to Jupiter. Its silent presence out there in the dark, pulling danger away, giving Earth the stability it needed for life to persist. A guardian you never see, doing its work without recognition, just by existing where it is. Galaxies form, cosmic web structure. Galaxies don't scatter randomly through space. They cluster along vast filaments of dark matter, forming a cosmic web that spans the entire observable universe. Between these filaments are enormous voids, regions with almost nothing in them. The structure looks organic, like neural networks or fungi mycelium, threads connecting nodes across incomprehensible distances. The universe has architecture, pattern, not chaos, but structure that emerged from the earliest moments after the Big Bang. You're sitting inside one of these filaments right now, part of the web, connected to everything else by gravity's invisible threads. Let's drift somewhere else now, somewhere softer. Black holes can merge and create gravitational waves. When two black holes collide, they don't explode. They spiral into each other, releasing energy as gravitational waves, ripples in space-time itself. In 2015, humans detected these waves for the first time. The collision happened over 1 billion years ago, but the ripples reached Earth only recently, washing over the planet like silent echoes of a cosmic event long finished. You pass through those waves without feeling them. Space-time bent around you, stretched and compressed by fractions of an atomic width, and you noticed nothing. The universe moved, and you moved with it, unaware. Always unaware. Venus rotates backward compared to most planets. Venus spins the wrong way. Most planets rotate in the same direction they orbit the Sun. But Venus rotates backward, retrograde, possibly because of an ancient collision that flipped its axis. It also rotates incredibly slowly. One day on Venus lasts longer than 1 year. Time moves strangely there. The Sun rises in the west and sets in the east, taking months to cross the sky. Everything about Venus defies expectation. It's a reminder that even in our own solar system, not everything follows the rules you assume are universal. Saturn's rings may be younger than dinosaurs. Saturn's rings might not be ancient. They're probably only a few 100 million years old, young by cosmic standards. They could have formed when a moon drifted too close and was torn apart by Saturn's gravity. Eventually, they'll disappear, pulled into the planet or scattered into space. This means there was a time before Saturn had rings, and there will be a time after. Right now, in the brief window of cosmic history when you exist, Saturn happens to have rings, a temporary beauty. You're lucky to live when you do, even if you never see them except in photographs. UY Scuti is one of the largest known stars. The largest known stars are almost incomprehensibly huge. UY Scuti, a red supergiant, has a radius about 1,700 times larger than the Sun. If you placed it where the Sun is, its surface would extend past Jupiter's orbit. It would swallow Earth, Mars, the asteroid belt, and keep going. These massive stars burn through their fuel quickly. UY Scuti will likely explode as a supernova within the next 1,000,000 years, tomorrow by cosmic standards. For now, it glows red and enormous in a distant corner of the galaxy, too far to threaten anything, just existing at a scale that makes your mind quiet with impossibility. Voyager probes still send data from interstellar space. The Voyager probes are still out there, still working. Launched in 1977, Voyager 1 and 2 have traveled farther than any human-made objects. They've left the solar system and entered interstellar space, the region between stars. And they still send faint signals back to Earth, messages from the edge of everything we know. They'll drift through the galaxy for billions of years, long after Earth is gone, long after the sun has died. Silent travelers carrying golden records with sounds and images of humanity, music and greetings in 55 languages. A message in a bottle, thrown into an ocean so vast it may never be found. Water exists throughout solar system. Water is more common than you might think. It's not just on Earth. Jupiter's moon Europa has a vast ocean beneath its icy crust. Saturn's moon Enceladus shoots water geysers into space. Mars has ice at its poles and possibly liquid water underground. Even distant moons like Ganymede and Titan show signs of water. The building blocks of life scattered across the solar system, hidden beneath ice, trapped in rocks, floating in space. Water, quietly present, waiting. The universe may be less barren than it appears. And that's a softer thought to rest with. You're doing perfectly, even if you've drifted away and come back. There's nothing you need to remember, just rest. Universe's expansion is accelerating. The universe isn't just expanding, it's speeding up. Galaxies are moving away from each other faster now than they were billions of years ago. Something is driving this acceleration, and we call it dark energy, but we don't know what it is. It makes up about 68% of all the energy in the universe, yet it remains invisible, unmeasurable, except by its effects. In the far future, the acceleration will pull galaxies so far apart that each one will be alone in the dark, unable to see any others. The sky will go black. But that's trillions of years away. For now, the universe is still filled with light, still connected, still expanding into the vast unknown. Supermassive black holes live in galaxy centers. At the heart of almost every large galaxy, there's a supermassive black hole. These aren't the black holes formed from collapsing stars. They're millions or billions of times more massive than the Sun. The Milky Way's central black hole, Sagittarius A star, weighs about 4 million solar masses. It sits there, quiet for now, pulling in gas and dust when it drifts close enough. You're orbiting it distantly. The Sun circles the galactic center, and you circle with it, held in a dance around something so massive it warps space itself. A silent anchor in the middle of everything, holding the galaxy together through gravity's patient grip. Pulsars are universe's most precise clocks. Some dead stars become clocks. When massive stars collapse into neutron stars, they spin incredibly fast, sometimes hundreds of times per second. They emit beams of radiation from their magnetic poles, sweeping across space like lighthouse beams. From Earth, we see these as pulses, perfectly regular, arriving with precision that rivals atomic clocks. These pulsars are so reliable that scientists use them to measure distortions in space-time. A spinning remnant of a star, keeping time across the void, sending signals that arrive exactly when expected. Even in death, there's order. Even in collapse, there's rhythm. Subsurface oceans exist on many moons. Beneath the ice of distant moons, there are oceans. Europa, Enceladus, Ganymede all have vast bodies of liquid water hidden under frozen crusts. These oceans are kept warm by tidal heating, the friction created as the moons are squeezed and stretched by their parent planet's gravity. Some of these oceans may be larger than all of Earth's oceans combined. And where there's liquid water, there might be life. Not on the surface, but deep beneath the ice, in the dark and the cold, sustained by volcanic vents and chemical energy. Entire ecosystems that never see sunlight. Worlds within worlds, quiet and hidden. Cosmic rays constantly bombard Earth. High-energy particles from space rain down on Earth constantly. They're called cosmic rays, but they're not rays, they're particles, mostly protons, traveling at nearly the speed of light. They come from supernovae, pulsars, maybe even black holes. When they strike Earth's atmosphere, they create cascades of secondary particles that shower down to the surface. You're being hit by them right now. They pass through you harmlessly, invisible and unfelt. The atmosphere shields you from the most dangerous ones. What reaches you is just a gentle rain of particles from distant explosions, cosmic debris that's traveled for millions of years to arrive at this moment. As you rest here, the same forces that shape galaxies are at work in you. Gravity, time, energy, all flowing through the moment you call now. And speaking of forces, galaxy collisions take millions of years. When galaxies collide, it happens slowly. Stars are so far apart that when two galaxies merge, individual stars almost never actually hit each other. The galaxies pass through one another over millions of years, their shapes distorting, their spiral arms twisting into new configurations. It's not a crash, it's a dance, a slow blending of two systems into one. The Milky Way will eventually collide with Andromeda. In about 4 billion years, the two galaxies will begin to merge. Our Sun will likely survive, just thrown into a new orbit, part of a larger galaxy with a new shape and a new name. Nothing violent, just transformation, patient and vast. Many asteroids come in pairs. Not all asteroids travel alone. About 15% of near-Earth asteroids are binary systems, two rocks orbiting each other as they move through space. Some are similar in size, others have a tiny moonlet orbiting a larger rock. They're held together by their mutual gravity, spinning around each other, traveling together through the dark. Even rocks find companionship. Even in the emptiness between worlds, things pair up and stay together, locked in their own small dance, moving through the solar system as one. Magnetars have universe's strongest magnetic fields. Some neutron stars have magnetic fields so strong they warp atoms. These are magnetars, neutron stars with magnetic fields 1,000 trillion times stronger than Earth's. If a magnetar existed within 1,000 kilometers of you, its magnetic field would be lethal, disrupting the molecular bonds in your body. Even from halfway across the solar system, it could erase every hard drive on Earth. But they're all far away, isolated in distant corners of the galaxy. Their power is contained by distance, their violence muted by the void. They exist as extremes, pushing the boundaries of what's possible, but too remote to matter to your quiet existence here. Light experiences no time. From light's perspective, no time passes. At the speed of light, time dilation becomes infinite. A photon emitted from a distant star doesn't experience the billions of years it takes to reach Earth. For the photon, the journey is instantaneous. It leaves the star and arrives here in the same moment, from its own reference frame. This is one of the strange truths of relativity. Light travels through time differently than you do. Every photon that touches your eye experienced its entire journey as a single instant, even if that journey took millions of years. Time, it turns out, is personal. Even light has its own experience of it. Galactic center contains complex molecules. The center of the Milky Way is not empty. In the dense clouds of gas surrounding Sagittarius A star, astronomers have detected complex organic molecules, amino acids, sugars, alcohols. These are the building blocks of life, floating in the chaos near a supermassive black hole, formed by the same chemistry that happens on Earth. Life's ingredients are everywhere, even in the most unlikely places. The universe doesn't hold these molecules preciously in one safe corner. It scatters them freely, lets them form wherever conditions allow. Chemistry doesn't care where it happens. It just happens, over and over, in the light and in the dark. Nothing here requires your attention. Your only task is to rest. Let yourself sink a little deeper. Breathe in if you'd like. Breathe out if it feels right. Or don't. Your body knows what to do. Andromeda Galaxy is approaching Milky Way. The Andromeda Galaxy is moving toward us. It's approaching at about 110 kilometers per second. In about 4 billion years, it will collide with the Milky Way. The two galaxies will merge, their stars mixing, their shapes transforming into something new. Probably an elliptical galaxy, less dramatic than the spirals we know now. By then, the Sun will be nearing the end of its life, and Earth will likely be uninhabitable. But the collision itself won't destroy anything. Stars are so far apart that they'll simply pass through each other, like two clouds of fireflies merging in the dark. Slow, gentle, inevitable. Cosmic microwave background surrounds us. You're sitting inside the oldest light in the universe. The cosmic microwave background radiation fills all of space. It's the afterglow of the Big Bang, stretched and cooled over billions of years. No matter where you go in the universe, you'll find it, a faint hum at about minus 270 degrees Celsius, present everywhere, always. It's the closest thing to a universal constant, the background against which everything else exists. A quiet reminder that the universe had a beginning, and that beginning still echoes through every cubic meter of space, including the space you're occupying right now. Some supernovae fail to explode. Not all dying massive stars explode. Sometimes, when a star's core collapses, instead of rebounding and creating a supernova, it just disappears. The core becomes a black hole so quickly that the explosion never happens. The outer layers fall inward, and the star vanishes from view, leaving behind only a black hole where a supernova should have been. These are called failed supernovae. The star dies quietly, without the brilliant flash that normally announces a massive star's end. Just a sudden absence. A light going out without ceremony. Even stellar death isn't guaranteed to be dramatic. Some galaxies are made almost entirely of gas. Not all galaxies have many stars. Astronomers have found galaxies that are almost entirely hydrogen gas, with very few stars formed. They're called dark galaxies or gas-rich dwarfs. The gas is there, the conditions seem right for star formation, but for some reason, stars haven't ignited. The galaxies remain dim, almost invisible, full of potential that hasn't yet been realized. They're reminders that not everything in the universe moves at the same pace. Some galaxies are old and full of stars. Others are still waiting, holding their material in reserve, as if they're not quite ready yet. And that's fine. The universe has time. Black holes can merge, creating new ones. When black holes collide, they become one. The collision releases enormous energy as gravitational waves, but the black holes themselves don't break apart. They merge, spiraling into each other, their event horizons joining to form a single, larger black hole. The final black hole spins rapidly, settling into a new equilibrium, carrying the combined mass of both parents. It's a strange kind of unity. Two objects that trap everything, including light, come together and become something bigger. Nothing is lost, just transformed, combined, continuing to exist as a single entity in the fabric of space. White dwarfs cool slowly over trillions of years. When a star like the Sun dies, it becomes a white dwarf. White dwarfs are the leftover cores, no longer fusing hydrogen, just glowing from residual heat. They cool incredibly slowly, taking trillions of years to fade completely. The universe isn't old enough yet for any white dwarf to have cooled completely to a theoretical black dwarf. This means every white dwarf that exists right now is still warm, still glowing faintly, still holding on to the heat of its last nuclear reactions. Even in death, stars take their time letting go. They cool so slowly, it might as well be forever. Time slows down near massive objects. The stronger the gravity, the slower time moves. This is gravitational time dilation. Near a black hole's event horizon, time slows dramatically relative to distant observers. If you could watch someone fall toward a black hole, they would appear to slow down, freeze, and never quite cross the horizon, even though from their perspective, they cross it quickly. Time is not a universal clock. It's local, personal, shaped by mass and motion. The universe doesn't keep one consistent time. It keeps countless times, each flowing at its own rate, depending on where you are and how fast you're moving. Intergalactic voids are mostly empty. Between galaxy clusters, there are vast empty regions. These cosmic voids can be hundreds of millions of light-years across, containing almost no galaxies, very little matter, just empty space. They're not completely empty. There's still dark matter and some scattered gas, but they're as close to nothing as the universe gets. The universe is mostly emptiness, held together by the gravity of what little matter exists. The voids are the background, the negative space that gives structure to the cosmic web. Silence surrounding the occasional note. Nothing giving meaning to something. Universe grows more transparent over time. The early universe was opaque. For the first 380,000 years, it was too hot and dense for light to travel freely. Then it cooled enough for atoms to form, and light could finally move through space. This is called the epoch of recombination. The universe became transparent, and it's stayed that way ever since. Over time, as galaxies formed and stars began to shine, the universe cleared even more. Radiation from the first stars ionized the remaining neutral hydrogen, opening up sightlines across cosmic distances. The universe opened its eyes, so to speak. And now you can see across billions of light-years, through space that was once a fog. We're moving deeper now, into the stillness. First black hole image captured in 2019. In 2019, humans saw a black hole for the first time. The Event Horizon Telescope captured an image of the supermassive black hole at the center of galaxy M87. It appeared as a dark circle surrounded by a glowing ring, the shadow of the event horizon against the bright accretion disk behind it. For decades, black holes were theoretical, mathematical predictions. Then they became real, visible, photographed. A shadow at the heart of a distant galaxy, 55 million light-years away, brought into focus by the combined efforts of telescopes across Earth. Something that was invisible became seen. It's completely fine if you don't hear another word I say. You're already where you need to be. Andromeda Galaxy visible to naked eye. On a clear, dark night, you can see another galaxy with your eyes alone. The Andromeda Galaxy appears as a faint, fuzzy patch in the sky, 2.5 million light-years away. The light reaching your eyes left Andromeda before humans existed. You're looking back in time, seeing a galaxy as it was when Earth was home to completely different forms of life. It's the most distant object visible without a telescope. A neighbor galaxy, close enough to see, far enough to put your entire existence in perspective. Just a smudge of light, carrying photons that traveled across the void to arrive at this exact moment where you happen to be looking up. LIGO detected gravitational waves in 2015. In 2015, humans detected ripples in space-time. The Laser Interferometer Gravitational Wave Observatory, LIGO, picked up gravitational waves from two colliding black holes over 1 billion light-years away. It was the first direct detection of these waves, confirming what Einstein predicted a century earlier. Space itself was bending, stretching, compressing as the waves passed through. You didn't feel it. The distortion was smaller than the width of a proton. But it proved that violent cosmic events send ripples through the fabric of reality, washing over everything, including you. The universe moves in ways you can't perceive, but it moves nonetheless. Some regions recede beyond observable horizon. The universe is expanding so fast that some galaxies are moving away faster than light can travel. This doesn't violate relativity. Space itself is expanding, carrying galaxies with it. Beyond a certain distance, galaxies are receding so quickly that their light will never reach us. They're crossing the cosmological horizon, disappearing from view forever. Every moment, more galaxies slip beyond this boundary. The observable universe is shrinking in a sense, even as the universe itself expands. Parts of reality are becoming permanently invisible, unreachable. The cosmos is larger than what you can ever see. Primordial black holes may fill universe. Some black holes might be as old as the universe itself. Primordial black holes could have formed in the first fraction of a second after the Big Bang, when density fluctuations caused regions to collapse directly into black holes. They'd be ancient, predating all stars and galaxies. Some scientists think they might account for some or all of dark matter. If they exist, they've been drifting through space since the beginning, invisible, undetectable except by their gravitational effects. Relics from the universe's birth still present, still exerting their pull on everything around them. Ghosts from the first moment. Quantum entanglement links particles across distance. Some particles remain connected no matter how far apart they are. When two particles become entangled, measuring one instantly affects the other, even if they're on opposite sides of the universe. It's not that information travels between them, it's that they're somehow still part of a single system. Einstein called it spooky action at a distance. The universe doesn't respect separation the way you might expect. Distance doesn't always mean disconnection. Things that were once together can remain linked in ways that defy intuition, bound by quantum correlations that persist across space and time. You don't need to understand it all. You just need to know you belong here, in this universe, in this moment, in this quiet. Vacuum energy may drive universe's expansion. Empty space might have its own energy. Vacuum energy, the energy of empty space itself, could be what's causing the universe's accelerated expansion. It's also called the cosmological constant. The idea is that even nothing has energy, and that energy pushes space apart. If this is true, then the vacuum isn't empty at all. It's filled with a subtle energy that permeates everything, a pressure that grows as space expands. The universe is being pushed apart by the very fabric of reality itself. Expansion driven by emptiness. Black holes emit Hawking radiation. Black holes aren't completely black. According to quantum mechanics, they emit faint radiation, Hawking radiation, due to quantum effects near the event horizon. This means black holes slowly lose mass over time, evaporating into space. For large black holes, this process takes trillions upon trillions of years. Eventually, every black hole will evaporate completely, leaving only radiation behind. Even the most massive objects in the universe will fade. Nothing is truly permanent. Everything in time returns to energy, to light, to the background hum of space. Some stars explode multiple times. A few stars don't die in one explosion. Supergiant stars can experience multiple eruptions before their final supernova. Eta Carinae, for instance, erupted in the 1840s, becoming one of the brightest stars in the sky for a time, then faded. It survived, but it will eventually explode as a true supernova, ending for good. Some endings are false starts. Some deaths are rehearsals. The star throws off mass, brightens, dims, and continues, until finally, one eruption is the real one, and the star becomes something else entirely, a process, not a single moment. Dark energy remains unexplained. We don't know what dark energy is. It makes up about 68% of the universe's total energy, and it's causing the universe to expand faster and faster. But we can only detect it indirectly through its effects. We don't know what it's made of, where it comes from, or why it exists. The majority of the universe is something we can't explain. That's not a failure of science. It's an acknowledgement of how much remains unknown. The cosmos holds most of itself in mystery, and that's okay. Not everything needs to be understood right now. Some things can just be. Kilonovae create heavy elements like gold. When neutron stars collide, they forge gold. The collision creates what's called a kilonova, an explosion that produces heavy elements like gold, platinum, and uranium. These elements can't be made in normal stars. They require the extreme conditions of colliding neutron stars. The gold in any ring, any piece of jewelry, was created in one of these violent cosmic events, then scattered into space, eventually making its way into the cloud that formed our solar system. Every atom of gold on Earth is a remnant of stars colliding billions of years ago. Precious not just because it's rare, but because of where it came from. Let yourself sink deeper. There's nowhere else you need to be. No words to follow, no thoughts to hold. Billions of galaxies remain invisible. Most galaxies are too faint to see, even with telescopes. They're there, billions of them, just beyond the reach of current instruments, waiting to be discovered. Trillions of exoplanets likely exist. There are at least as many planets in the Milky Way as there are stars, probably more. That means hundreds of billions of worlds in our galaxy alone. Universe may be perfectly flat. Measurements suggest the universe has zero curvature. It's flat, extending infinitely in all directions. Not curved like a sphere, not saddle-shaped, just flat. Star formation will eventually cease. In about 100 trillion years, the last stars will form. After that, the universe will slowly darken as existing stars die out one by one. Black holes spin at incredible speeds. Some supermassive black holes rotate at nearly the speed of light, dragging space-time around them like water swirling down a drain. Early galaxies were smaller and clumpier. The first galaxies were much smaller than today's, irregular, chaotic, gradually merging and growing into the massive spiral and elliptical galaxies we see now. Fast radio bursts remain mysterious. Brief, intense pulses of radio waves arrive from distant galaxies. We've detected hundreds, but we still don't know what causes most of them. Solar system orbits galactic center. Our entire solar system is orbiting the center of the Milky Way at about 230 kilometers per second. One orbit takes about 230 million years. Earth's atmosphere protects us daily. Every day, Earth's atmosphere burns up tons of space debris, meteors that would otherwise strike the surface. Most never reach the ground. Mars once had flowing water. Ancient riverbeds and lake basins on Mars suggest it once had liquid water on its surface, perhaps billions of years ago, before its atmosphere thinned. Most stars born in clusters. Stars typically form in groups, hundreds or thousands together in stellar nurseries. Over time, these clusters disperse and the stars drift apart. Tidal forces reshape moons and planets. Gravity doesn't pull uniformly. It stretches objects, creating tides. This force shapes moons, causes volcanic activity, and slowly changes orbits over time. Neutrinos pass through everything. Trillions of neutrinos pass through your body every second, arriving from the sun. You never feel them. They interact so weakly with matter, they pass through Earth itself. Planets orbit binary star systems. Some planets have two suns. They orbit binary star systems, experiencing double sunsets and complex patterns of light and shadow. Cosmic web spans observable universe. The largest structure in the universe is the cosmic web, filaments of galaxies stretching across billions of light years, surrounding vast, empty voids. Earth's rotation is slowing down. Days are gradually getting longer. Earth's rotation slows by about 1.7 milliseconds per century due to tidal friction with the Moon. Some meteorites come from Moon and Mars. Not all meteorites are from asteroids. Some were blasted off the Moon or Mars by ancient impacts and eventually fell to Earth. Gravity travels at speed of light. Gravitational changes don't happen instantly. If the Sun suddenly disappeared, Earth would continue orbiting for 8 minutes before the change in gravity reached us. Black holes detected by their effects. We can't see black holes directly, but we detect them by watching stars orbit invisible points in space, or by the radiation from matter falling in. Cosmic background temperature is uniform. The temperature of the cosmic microwave background is almost exactly the same in every direction, about 2.7 Kelvin, with tiny fluctuations. Massive objects twist spacetime. Rotating massive objects drag spacetime around them, creating a twisting effect called frame dragging. The effect is subtle but measurable. Some cosmic regions forever isolated. Due to expansion, some regions of space will never be able to communicate with each other. They are causally disconnected, forever separated by distance. Heavy elements come from stellar explosions. Every element heavier than iron was created in supernova explosions or neutron-star collisions, then scattered into space. Light stretches as universe expands. Photons traveling through expanding space get stretched, shifting toward the red end of the spectrum. This is cosmological redshift. Sound waves shaped early universe. Pressure waves in the early universe's plasma created the pattern of hot and cold spots we see in the cosmic microwave background. Galaxies absorb smaller galaxies. Large galaxies grow by consuming smaller ones. The Milky Way is currently absorbing several dwarf galaxies. Some stars pulsate rhythmically. Variable stars expand and contract regularly, brightening and dimming like cosmic heartbeats. Their periods can last days, months, or years. Rogue black holes drift through space. Some black holes don't stay in one place. They were ejected from their galaxies during collisions and now wander through intergalactic space. Black hole mergers can kick systems out. When black holes merge, the gravitational waves can create a recoil, kicking the resulting black hole out of its galaxy at high speed. White dwarfs crystallize over time. As white dwarfs cool, their cores crystallize into solid carbon and oxygen, essentially becoming cosmic diamonds floating in space. Universe's ultimate fate remains unknown. We don't know if the universe will expand forever, collapse, or something else. Its future depends on forces we're still trying to understand. Supernova remnants enrich space. The shells of gas expanding from supernovae carry new elements into space, enriching clouds that will form the next generation of stars. Planets can gravitationally lens starlight. When planets pass in front of distant stars, their gravity can bend and magnify the light, revealing the planet's presence. Early universe glowed orange-red. When the universe first became transparent, it glowed with the light of hydrogen atoms forming. That glow would have looked reddish-orange to human eyes. Universe doesn't cool uniformly. Some regions cool faster than others due to differences in density. These variations created the seeds of galaxies and clusters. New universes might bud from black holes. Some theories suggest black holes could spawn new universes, each with its own space and time, completely disconnected from ours. Cosmic inflation left gravitational imprints. The rapid expansion in the first moments after the Big Bang may have left patterns in the cosmic microwave background that we can still detect. Most matter never formed stars. The majority of ordinary matter in the universe remains in diffuse gas clouds, never collapsing into stars or planets. Universe contains more questions than answers. For every cosmic mystery we solve, new questions emerge. The universe is vast, ancient, and still full of secrets waiting to be uncovered. And finally, one last fact to rest with. You are made of stardust. The carbon in your cells, the calcium in your bones, the iron in your blood, all of it was forged in the heart of a star that died long before Earth was born. You are not separate from the universe. You are a piece of it made conscious. A moment of the cosmos, aware of itself. And that is perhaps the most relaxing fact of all, that you belong here, woven into the fabric of everything that is. We've traveled through the universe tonight, through dying stars, bending light, quantum fields, and the vast quiet between galaxies. You don't need to remember any of it. You don't need to have heard every word. You are here, and that's enough. You are not separate from the cosmos. You are a moment of it made conscious. And now, as you rest, you return to the stillness from which all things emerge. One more slow breath, or none at all, whatever comes naturally. And now, just rest. Good night.